My name is Shuyu. Now I'm presentation for my small supermarket inventory management app. For step 1, let's talk about the business background and the problem we aim to solve. My app targets small supermarkets which often struggle with inventory management. Currently, many of these businesses rely on paper or notebooks to record their inventory, such as the name and quantity of goods they receive. This method is outdated and risky. Paper can easily be lost, damaged, or misread, leading to errors in stock tracking. The problem is clear. Small markets aren't utilizing modern tools to make their operations more efficient and secure. My app solves this by allowing them to store inventory data digitally in Google Forms, which is a much safer and more reliable solution. Okay, let's move to the next slide. On slide 2, I will explain how the app addresses the problems and its benefits. The app provides a simple interface where users can input the name and the quantity of goods, which are then saved locally and uploaded to Google Forms. This replaces unreliable paper records with a digital solution, ensuring data is secure and accessible. For the business, this means accurate record keeping, no more lost or damaged papers. For users, they can easily track when inventory are added, helping them manage stock more effectively. It also reduces errors and save time compared to manual methods. The app empowers small markets to modernize their operations with minimal effort. Okay. And next, step 3 outlines the new workflow for inventory management using the app. Previously, supermarket staff would write down inventory details in a notebook, which was prone to errors and makes it hard to track past records. With the app, the process is streamlined. Staff open the app on their mobile device, enter the item name and the quantity, and click Add to save the data locally and upload it to Google Forms. They can also use the Find button to search for specified items without refresh the list or delete to clear all records. This digital approach ensures records are always accessible and organized, making inventory management fast and more reliable. Now, let's explore the app's face in more detail. On step 4, I will highlight the key features of the app, which you can see in the screenshot. First, the add features users enter an item's name and quantity in the text field, and when they click Add, data is stored locally in TinyDB and sent to Google Forms via an HTTP request. Second, the Find feature allows users to search for items by name. With click Find, the app searches the records and displays the first matching results in the list wheel. Third, users can add or delete records by selecting the item from the list. They can update its name or quantity or delete it entirely. There's also a delete button to clear all records. The reload button refreshes the list wheel to show the latest data from TinyDB. The app uses a simple UI with a list wheel to display records, buttons for actions, and a label to show raw data for debugging. Finally, it supports persistence storage, both locally with TinyDB and in the cloud via Google Forms. These features can make inventory management intuitive and efficient for small markets. Let's move on how to do data stones. Slide 5. Discuss the data structures used for persistent storage in the app locally. With TinyDB, a simple key value database in MIT App Inventor, the data structure is a list of dictionaries stored under the tag customer data. Each dictionary represents a record with two keys, name for the item name and the number for the quantity. For example, name, item 1, name 10, name, item 2, name 20. This structure allows quantity access to records on the device. For cloud storage, the app submits data to Google Forms using HTTP GET because the form has two fields, and entry as a number for the name and entry and the number for the quantity. The app contains a URL. This backs up security in the cloud. The app first saves data locally in TinyDB, then uploads it to the Google Forms, providing both local access and remove backup. Next, let's look at how we tested the app. On slide 6, I will explain how testing plan to ensure the app works correctly. We conducted functional tests to verify each feature. For the add feature, we enter an item name and quantity, then check if the data was saved in the TinyDB and prompt in Google Forms. From the find feature, we searched for the item and confirmed the correct result appear in the list view. We also tested editing and deleting records to entry checks were reflected in both TinyDB and the list view. For error cases, we tested with the empty inputs to check error handling and add a large number of records to evaluate performance. Finally, we did user testing by simulated real-world usage with small supermarket staff to ensure the app is user-friendly. These tests helped confirm the app's reliability. Okay, let's move on to final step. For final step, I discuss apps, limitations, errors, and future plans. One limitation is that app requires an internet connection is update data to Google Forms. If there's no connection, data stays in TinyDB but isn't sized. Another limitation is the search functionality. Only find the first machine record and stop, which might miss other matches. Additionally, there's no user authentication or data encryption, which could be a security concern. On error side, if internet fails, data won't send to Google Forms, though it remains safe in TinyDB, so an incorrect Google Forms URL could prevent data submission. For future improvements, we plan to add an offline modem with automated silencing. When the device is online, enhance the search to show all machine records, enhance user authentication and encryption for security, and add analyze to track inventory trades over time. These updates will make the app even more robust and useful for small supermarkets. Thank you.